velocity and acceleration have opposite signs. So if you are moving in the right direction, but think about if you are moving right in a car, but then now you are slowing down from 30 to 25. Because your acceleration is decreasing, but you're going in the positive direction, you're actually slowing down. And so we are taking a look at actually every other spot that we didn't, if it's the opposite. If it's not speeding up, it's slowing down. So this piece right here has negative velocity but positive acceleration. So we would say from time 1 to 3, again right here, velocity is negative, but acceleration, the slope, is 0. And so it is speeding down. Same thing right here. Velocity is negative, but its slope or acceleration is positive. So that is also slowing down. So we would say in union with time of, 4 to 7. And lastly, this piece right here. Velocity is positive. However, the acceleration, the slope of the velocity is negative, so it is slowing down. So we would say in union with 9 to 10. This one is kind of tricky because you're looking at the rate of rates and you're looking at the slope of stuff. We will do a lot more practice with this here, but slowing down, speeding up, there we go. Lastly, with this, when is the particle moving the fastest and when is it at a constant speed? So the fastest just means the largest speed. So remember, speed is the absolute value. There we go. Speed is the absolute value of velocity. So it actually doesn't care about the sign here, just what has the highest number. And when we do our ordered pair here, 4, -4, and 5, -4, any other ordered pair does not have a higher velocity or higher speed. And so time equals 4 and time equals 5 as the fastest is when the particle is moving the fastest. It's just in the left direction, but again, the absolute value of that is the highest value at 4 and 5. And then it's at a constant speed is when the change of velocity equals 0. Well, change of velocity, that is actually acceleration. Constant speed means we are not speeding up or slowing down. Our acceleration is 0. Well, acceleration is the slope of velocity. So we're looking at when slope is 0 or a flat line, and that actually happens on the interval of 4 to 5 seconds. So basically at 4, it hits its highest speed, it stays constant until time of 5 seconds, and then it changes after that. Now we can also graph other graphs from our velocity graph. So if we want to graph the acceleration of our velocity, remember acceleration is the slope of velocity. So we're basically saying, we're going to break it up and say, from time of 0 to time of 1, that slope is a -1 slope. Remember, we're putting open dots because at whole numbers, a lot of times they change. And when the derivative coming in is not the same as the derivative going out, there is no value at that derivative. All right, then we change to this segment right here. Well, this slope is 1/2. So from time of 1 to time of 3, we have a slope of 1/2. We'll keep that up. Now we have a slope of -4 from time of 3 to time of 4. We have a slope of 0 I'm going to change this to an A, not a V now. Then we get this segment slope of 2 for a long time. Let's see, that is time 5 to 7. It's a slope of 1. And then a slope of -3 for that last bit. So again, acceleration graphs the slopes of velocity. And lastly, if we wanted to graph speed, remember speed is the absolute value of velocity. So whatever these ordered pairs are, we're actually just taking the absolute value of them and graphing them as if they were all positive. And so when we do that, we actually get 0, 0. 1, -1 turns into 1, +1. That one stays, but 4, -4 actually comes up here. 5, -4 comes up here. And then everything else is just positive, so it stays where it is. But now when we look at the speed graph, I actually really love this because it's a lot easier to see where things are speeding up and slowing down. So remember, in speed, everything is positive velocity, but we can see that these positive slopes in the positive velocity show speeding up. And that's in line with what we saw before with those intervals. And then in this velocity, we can actually see where things are slowing down when we have a negative slope. And then we can actually see here, that's constant. Okay, so that ends our lesson. However, if you want to do the rest of 3.4, there is a video of another teacher teaching this lesson. I just want to make my own video because I want you to hear my consistent language with this stuff. But the other part, if it's like more economic stuff, you are welcome to watch it. It'll probably be like an extra credit question in the future, so if you don't watch it, no harm done. If you want to, watch the other video. Again, it's not me, but you could finish 3.4 if you want, or you can end here. Otherwise, I hope you have a great rest of your virtual day. Please reach out if you have questions, and I will see you tomorrow.